Hey fellow problem solvers, today I'm going to talk about angular and linear velocity, but before I do, let me ask you a question, and I did this in a short video. As you look at this wheel and I spin it around, there's numbers 1, 2, and 3 on there. Which one's spinning faster, the 1, the 2, or the 3? If you said the 1, you're right. If you said they're all spinning at the same speed, you're right. If you said the 3, then you're wrong. But if you said they're all going at the same speed, well, it depends what you're talking about. But if you're talking about angular velocity, rotation over time, then they are going at the same speed. If you're talking about linear velocity, distance over time, then the one's going faster, but it's a larger circumference, so it travels more distance over time. So the equation that relates these three things is linear velocity is equal to radius times angular velocity, and angular velocity has to be in radian measure. Really useful equation. It's kind of essential for working on cars, working on motorcycles, bicycles, working in a machine shop, wood shop. Anytime you got a circular motor and a blade attached to it, there's some sort of gearing, and that's usually done with angular and linear velocity. So let's put the camera over my shoulder and we'll get started on this really important idea. The first step is identifying your three variables. The first variable is the lowercase v. It stands for linear velocity. The units are going to be some sort of distance over time, like miles per hour or feet per second, but it has to be a linear distance over time. The second variable, radius, is some sort of distance, miles, feet, centimeters. And the third variable is actually a lowercase omega. I know it looks like a W, but it's actually a lowercase omega. It represents angular velocity, and that's some sort of rotation over time. You see this a lot in a pre-calculus class, trigonometry class, physics, and then a lot of unit cancel like you would do in chemistry. If you have a circle like that, you know the radius is equal to r, and the circumference is 2 pi r. If it's a unit circle, the radius is equal to 1, so the circumference is equal to 2 pi. So that's why we're using this equation in trig, or why we're doing it in this class, is that 2 pi and 1 revolution are going to be equal. Linear velocity would be circumference times angular velocity, right? How many times it goes around by the length of that line would be circumference, and that would give you how much distance it travels over time. But you could replace circumference with radius, knowing that the angular velocity has to be in radian measure. So that's the key. So again, three variables. First step is identifying those variables. You have to have any two of these in the equation to solve for the third. Let's do this problem right here. Let's say I have a circle with radius equal to 7 inches, and the angular velocity is 20 RPM, 20 revolutions per minute. Try and draw out your fractions like fractions and keep the revolutions in the numerator and the minutes in the denominator. So again, the equation is linear velocity equals radius times angular velocity, but this has to be in radians. So I convert this to radians to start with. 1 revolution is 2 pi radians. I multiply those. My revolutions cancel, and that's going to give me 20 times 2 times pi radians per minute. Still in angular velocity, but now I'm in radians per minute. Next step is to find the linear velocity. That linear velocity is going to be equal to the radius, 7 inches, times the angular velocity in radian measure, 40 pi rads per minute. And as you remember, radians are actually unitless. So that's written in there really just as a placeholder. So those are the only units that just kind of come in and come out, because they're not units. They're actually unitless by definition. So I'm going to do this number 7 times that number 40, 280 times the pi, and that's going to give me 280 pi inches per minute. I know that's a distance over time, so it's a linear velocity, and that all kind of makes sense. Okay, here's a much more complicated one. Let's say I have 2 gears. This gear on the inside is gear 1 with a 3-inch radius. This gear on the outside is gear 2 with a 10-inch radius. Let's say I'm actually given a linear velocity of gear 1 at 20 feet per second. And I'm asked to find the angular velocity of gear 2. So I use that subscript gear 2. Well, I only have one piece of information for that angular velocity for gear 2, and that is only the radius, so I need more information. But I do have two pieces for the blue gear, gear 1. I have its linear velocity and its radius. If linear velocity is equal to radius times angular velocity, I could divide both sides by radius and see that angular velocity is equal to linear velocity divided by radius. Angular velocity of gear 1 is going to be equal to the linear velocity of gear 1, 20 feet per second, divided by its radius, or multiplied by the reciprocal, so multiplied by 1 over 3 inches. Those actually are not going to cancel because they're feet and inches, so I got to do a unit conversion. Angular velocity is 20 feet per second times 1 over 3 inches. And then I know there are 12 inches in a foot. So now I'm going to have my feet cancel with feet, my inches with inches, and I have 20 times 12 divided by 3, 80, no units in the numerator, over seconds. So since there are no units in the numerator, the only units I could put in are radians. So the angular velocity of gear 1 is 80 radians per second, but these two gears have the exact same axle, so they go around the same number of times. So if gear 1 has an angular velocity of 80 rads per second, gear 2 will also have an angular velocity of 80 rads per second. Let's take a look at a really complex problem here. Now I have 3 gears. They have 2 gears with the same axis and 2 gears connected by a drive belt. Gear number 1 in red here has a radius of 5 centimeters. Gear 2, a radius of 9 centimeters. Gear 3, radius of 7 centimeters. And the only thing I'm given is a linear velocity of gear 2 at 50 centimeters per second. So go ahead and find the angular velocity of gear 3. There's probably 5 separate problems in this. First thing you're going to do is find angular velocity of gear 2. That'll be equal to angular velocity of gear 1. Then find the linear velocity of gear 1. That'll be equal to the linear velocity of gear 3. Go backwards to find the angular velocity of gear 3. So go ahead and pause the video and do that problem. And then when you're done, go ahead and watch me do the problem and see if it's right. Or just fast forward to the end and see if you got it. So again, the main equation is linear velocity equals radius times angular velocity. This has to be in radian measure. Or if I were to divide both sides by radius, angular velocity is going to equal linear velocity divided by radius, or multiplied by the reciprocal of radius. So I only have 2 variables for my purple gear, 9 centimeters and linear velocity. So the angular velocity of gear 2 in purple is going to be its linear velocity, 50 centimeters per second, divided by its radius, or multiplied by 1 over 9 centimeters. Centimeters are going to cancel. That's not going to give me any units in the top. So by default, that's radians, the only unit I could just put in or take out. And then that's going to be radians per second. On my calculator, I'm going to do 50 divided by 9 and get 5.5, 5.6. So that's 5.6 radians per second. That's the angular velocity of gear 2 in purple, but it is also the angular velocity of gear 1 because they have the same axle or the same center point. So angular velocity of gear 1 and gear 2 are equal, and they're 5.6 radians per second. Now that I have that, I can find the linear velocity of gear 1. So the linear velocity of gear 1 is equal to its angular velocity, 5.6 rads per second, times its radius of 5 centimeters. Radians will just drop out because it's really a placeholder. It's kind of unitless. And then I take that stored value on my calculator right there, the 5.555, multiply it by 5, and I get 27.8. But I keep that value on my calculator. So the linear velocity of gear 1 is 27.8 centimeters per second. But this belt travels at a constant speed. So if the linear velocity of that red gear is at 28 centimeters per second, it's also the linear velocity of gear 3. So the linear velocity of gear 3 is equal to the linear velocity of gear 1. The next thing I need to do is find the angular velocity of gear 3. So the angular velocity of gear 3 will be its linear velocity divided by its radius, 27.8 centimeters per second. Its linear velocity times 1 over its radius, 1 over 7 centimeters. Centimeters cancel. No units in the numerator, so it must be radians. Then I have that stored value on my calculator there, 27.777 divided by 7 gives me 3.97. So I have 3.97 radians per second. And that's my final answer. It's an angular velocity because it's rotation over time. If it said converted to RPM, it would still be an angular velocity. I would have 3.97 radians per second times a factor of 1, 2 pi rads equal 1 revolution. And then I would take that same value that's stored on my calculator at 3.97 and divide it. I'm going to do open quantity, 2 pi closed quantity. So I take that answer divided by 2 pi and I get 0.63. This is still an angular velocity. However, it is now in revolutions per second, or RPS, revolutions per second. If you have any questions, please post them in the comments below. I'll try and get back to them or make a video. Hope you enjoyed the video or hope it was helpful. Thank you for watching.